Hey everyone, welcome back to the channel. This is part 2 of our QR payment system series. In part 1, we built the QR code generation feature, where users can display their QR code to receive payments. If you missed that video, I'll link it in the description. Go watch it first, because we're building directly on top of that code. Today, we're completing the system by adding a live camera scanner to scan QR codes, a beautiful payment confirmation screen, Firestore transaction processing with atomic updates, complete integration with success notifications. By the end of this video, you'll have a fully working payment system that's ready for production. Let me quickly recap what we built in part 1. We have a QR payment page with 2 tabs. The first tab shows the user's QR code, and the second tab is currently empty. That's what we're building today. One important thing, for camera access on Android, open Android manifest.xml and add this permission before the application tag. For iOS, the MobileScanner package handles permissions automatically, so you're good to go there. All right, let's start coding. Let's build the Scan QR tab. This will use the device camera to scan QR codes. We create a MobileScanner controller to control the camera. The is processing flag prevents multiple scans while we're already processing one. Imagine scanning the same QR code multiple times by accident. Don't forget to dispose of the controller. This is important for cleanup and preventing memory leaks. Now, the main logic, processing the QR code data. First, we check if we're already processing. If yes, we return immediately. Otherwise, we set processing to true. Now let's decode and validate the QR data. We decode the JSON string back into a map and extract the receiver's user ID and name. Remember, we encoded this in part 1. Now for some important validations. First, we make sure the user is logged in. Then, and this is important, we check if the user is trying to scan their own QR code. That wouldn't make sense, right? You can't pay yourself. If everything checks out, we navigate to the payment confirmation screen. We pass the receiver's information to the confirmation screen. The await here is important. We wait for the user to complete or cancel the payment. If the payment was successful, result is true, we navigate back to home. If anything goes wrong, we show an error snack bar. And finally, we always reset the processing flag. Now for the UI. This is going to look really cool. The MobileScanner widget activates the camera. The onDetect callback fires whenever a QR code is detected. We check if we're not already processing, then extract the code and process it. Now we add a nice overlay on top of the camera. This creates a semi-transparent black overlay that darkens everything except our scanning frame. We use a column to center our scanning frame. This white square shows users where to align the QR code for scanning. To make it look even better, let's add animated corner decorations. We're positioning colored corners at each edge of the scanning frame. I'm using green accent color to indicate this is an active scanner. Green means go or active in UI design. We do this for all 4 corners: top left, top right, bottom left, and bottom right. Each one has borders on 2 sides to create that corner effect. Below the scanning frame, we add instructions. This creates a nice pill-shaped instruction chip that floats below the scanning frame. It's clear and easy to read against the dark overlay. Finally, we show a loading indicator when processing. When processing is true, we show a white card with a loading spinner and text. This gives users feedback that something is happening, and that completes our scanner UI. It looks professional and works smoothly. Now for the payment confirmation screen. This is where the magic happens. This screen receives the receiver's user ID and name as parameters. These are passed when we navigate here from the scanner. In the state class, we need two text controllers, one for the amount and one for an optional note. We also track the processing state and the sender's current balance. In its state, we immediately load the sender's balance. This fetches the balance from Firestore so we can display it to the user and validate they have enough money. Don't forget to dispose of the controllers. Now let's handle the payment confirmation logic. First, we validate the input. Is there an amount? Is it a valid number? Is it positive? Next, we check the balance. This prevents users from sending more money than they have. All of these validations happen on the client side for instant feedback. If everything checks out, we process the payment. If successful, we show a green success message and return true to the scanner. If it fails, we show a red error message and stay on the screen. Now for the most critical part, the Firestore transaction logic. This needs to be bulletproof. We're using Firestore batch writes. This is crucial. A batch ensures that either all operations succeed or none of them do. This prevents situations where money leaves one account but never reaches the other. We get references to both user documents and fetch their current data. If either doesn't exist, we throw an error, can't transfer money to non-existent accounts. We extract the current balances and the sender's name. We do one final server-side check for sufficient balance. This is the authoritative check, because the balance might have changed since we loaded it on the client. Now we update the balances. Simple math. Subtract from sender, add to receiver. These updates are added to the batch but not executed yet. Now we create transaction records. We generate a unique transaction ID and use server timestamp to get the exact server time. This ensures consistency across different time zones and devices. This creates the sender's transaction record. Notice the type is debit, money leaving the account. We include all relevant information: who sent it, who received it, the amount, a description, and the optional note. This creates the receiver's record with type, credit, money coming in. Both records have the same transaction ID prefix, so we can link them together if needed. Finally, the moment of truth. This single line executes all the operations atomically. If anything fails, everything rolls back automatically. This is what makes our payment system reliable. Now let's build the beautiful UI for the confirmation screen. standard app bar with our theme colors and a back button. Now for the recipient card. This creates a stunning gradient card that really stands out. The shadow gives it depth. We display Pay To at the top, a large user icon, and the recipient's name in bold. This makes it crystal clear who's receiving the money, reducing mistakes. Next, the Amount Input section. The amount input is styled with a large font size, 32 pixels. This makes it the focus of the screen. The $ prefix is also large and bold. I'm using a number keyboard for easy input. Below that, we show the available balance. This helps users know if they can afford the payment without trying and getting an error. Then the optional note field. A multi-line text field for adding personal notes like, "Thanks for lunch" or "Rent for December." Finally, the action buttons. a large, prominent Confirm button. When processing, it shows a loading spinner. When disabled, it becomes unclickable. And a simple cancel button to back out if needed. This completes our payment confirmation screen. Alright, let's test the complete flow from start to finish. First, I logged in as Eddie at Gmail. Eddie at Gmail don't have any money. Meanwhile, Eddie at Yahoo sees it. He want to transfer some of the money to Eddie at Gmail. He asks him to open his QR code. Then Eddie at Yahoo open its QR scanner. After entering some amount and write some notes, he confirmed the payment. See, his balance now, already deducted. Let's check Eddie at Gmail balance. Yes, he received it. Now Eddie at Gmail can go dining with his wife. If you want to support Eddie too, no need to scan the QR code. Just like, subscribe, and share this video. It really helps me. The complete source code for both parts is available on GitHub, link in the description. Drop a comment if you have questions, suggestions, or if you want to see other features added to this banking app. I read every comment and love hearing from you. Thank you so much for watching, and happy coding!